Great, so it's my honor to introduce our last speaker of the day, John Cooley, Jr. We'll be talking about common loons and climate change and their response in the Monadnock region. So John Cooley is a senior biologist with the Loon Preservation Committee, where he has coordinated field monitoring, nest site management, and loon rescues throughout New Hampshire since 2005. He holds a master's degree in conservation biology from Antioch University, New England.
Thank you. Yeah, I'm John Cooley, biologist at the Loon Preservation Committee. And my first connection with loons was 15 or 20 years ago as an Antioch student when I borrowed the New Hampshire loon data set for a statistics assignment. So it's good to be back in Keene sharing with you more recent findings from LPC's work to understand the impact of climate change on common loons. This has been a team effort at LPC with coworkers there and then collaborators who've helped with the stats and with looking at wildlife health and disease and climate change. So Ellen Martinson studies avian malaria at the University of Vermont, and Dr. Pokris has been central to all of our study of loon health and mortality. And then as a grassroots organization, we're depending on amazing seasonal field crews every year and volunteers around the state to help collect the data and then implement the conservation work that we do based on the data. And we get great photos from the volunteers too. So all the photos in this show are from that source. So we've been at the Loon Preservation Committee working since 1975 to protect a healthy population of loons in the state, to recover that population, and to use loons as an indicator species for the health of the aquatic ecosystem. We put out nest rafts. Let me see if I can go back. We put out nest rafts like this one to increase the productivity of the population. And then we also focus on, we floated 140 of those rafts this year. We focus on threats to, it's a little jumpy, threats to adult mortality. So the primary one there is the ingestion of lead fishing tackle. And we've documented that as the leading cause of death in adult loons in New Hampshire, and the biggest constraint right now on population recovery. So in 2016, lead sinkers and jigs were banned for use and sale in New Hampshire. And this is really a success story in the making, hopefully, as we monitor now the reduction in mortalities that should result as this policy takes effect. In the Monadnock region, our monitoring has found gradual recovery over the decades. And on the vertical axis here, you're seeing the number of paired adult loons that we count each year. And that's more than tripled in the Monadnock region. And across the state, we've seen the same trend, more than triple the number of occupied territories since the early 80s. This is still leaving a lot of room for growth. If you look at the map, you'll see the black dots showing you where we found paired loons this summer. And then it's a little bit harder to see, but the hollow circles are lakes we surveyed as suitable habitat, but that weren't occupied by loons yet. So we're over halfway towards what we estimate to be the carrying capacity in the state, but there's lots of room to grow. And the take-home message from this graph and map is really that over decades of intensive management, we're basically headed in the right direction. That's a little bit about LPC and the status of loons based on the recent past in New Hampshire. And now I want to just look to the future and focus more on climate change. And it's not good news. This is the National Audubon forecast for the retraction in the loon's breeding range in North America over the next approximately 50 years. The 3 degrees Celsius warming scenario is what we're due to hit at about 2080 under the high emission scenarios. And you can see this predicts that we'll lose breeding loons from the lower 48 at that point. And the question is, you get this prognosis if you're a loon biologist or if you just are interested in loons, is how certain you can be about this. How confident should we be in this forecast this far out, 50 years in the future, with so many unknowns across a vast spatial scale, and with, as an existential threat, a risk that we really can't afford to wait for hindsight to prove or disprove. We have to figure this out, and fast. So what we want to know is these climate envelope projections are based on the correlation between current climate and current distribution, and they assume that that's going to hold true over the years. So we want to know, if we could crystal ball it, whether that really does happen that way for the average species or for our species of interest. And there are a few studies, a growing number of studies, that have looked at that. This is the close-up for New England, all in red. But there was a work out in California to resurvey in the black boxes there on the Sierra Nevada transects that were originally surveyed for bird abundance in the early 20th century. And in the early 2000s, a team went back and surveyed them again with the benefit for their study purpose of a century of climate change. And they could see whether species that were originally in the early 20th century associated most closely with temperature or precipitation were tending to follow the climate shifts, and there had been climate shifts over the century in where they were found the second time around. I've circled the diagonal on this table here because it's what you would expect if species track their climate envelope or their Grinnellian niche in the title of the paper. Most of them did. And I want to point out, too, though, that the species that aren't on the diagonal there are ones that didn't follow what would have been expected based on their original associations. So it's a complicated picture. You have, a dozen or more of the species. Whoop, I'm going to go back to that for a minute. A dozen or more of those species that do, if they were associated with temperature, follow temperature. But some that were associated originally with temperature follow precipitation or both variables. And that detail is important because it speaks to the complexity of the drivers, the climate drivers, that really shape how a species is going to respond. And that's what we care about if we're managing the species in New Hampshire and trying to figure out what to do. So for loons in New Hampshire, this life cycle diagram is a way to parse out the potential impacts that we want to look at. Juveniles are on the left, adults are on the right, and those arrows show you the transitions between the life stages. So the one we often care the most about is the fecundity at the top there, where adults each nesting season produce juveniles, and then off on the ocean, the juveniles spend a couple years and eventually are recruited back into the population as adults. That's the G arrow in the middle. And those lower P arrows represent annual survival in each life stage. We can ignore a bunch of the potential climate impacts here at first because we just don't have the data. So the juveniles on the ocean, we're not going to worry about right now, even if there are important effects. And in terms of the habitat that loons depend on and all the indirect impacts that climate change will have on that, it's not going to kill the loon, but it may affect the lake where they live. The critical impacts there are beyond the scope of what we can first look at LPC. So here's a slide of a loon chick on Cold Spring Pond in Stoddard eating the adult phase of eastern newt. And I put it up here just to emphasize the diversity of the prey ecology that's affecting loons and how complicated it is and how far beyond the scope of what we could start with was. So we wanted to start with data we already had easily in hand, effects on adult survival that we're noticing, and also during the nesting season on nesting success. When it goes well, loons make nesting look easy. So here's a loon chick starting to go down into the water, join its parent there after 4 weeks of incubation. And this tranquil scene is actually the product of a very precarious 4 weeks. Loons are forced to nest right at the water's edge. They can't move around on land. And so a nest can be high and dry if the lake level drops. The loon is sitting out in the summer heat with basically a down sweater or a waterproof dry suit on. And if we get too much rain, the nest can be flooded. This is a nest on Seaver Reservoir in July 2021, and I'll talk a little more about that rain event in a few slides. But we know from all these years of monitoring that a really rainy summer can devastate the nesting success of the population. And we wanted in this climate analysis to go a little bit beyond that and look at other weather variables. So this map shows you all the weather stations around the state that are part of what's called the Global Historic Climate Data Network. It's easy data for the public to download, and we stitched that data together with the nearest neighbor nest attempts throughout the monitoring record, over 4,000 nest attempts, and matched also for the daily weather, the precipitation, temperature, and relative humidity data for each individual nest, and modeled the nest outcome at each individual nest based on that weather. And we weren't really trying to come up with the grand unified theory of loon nesting, but we wanted to include other important covariates so that we could tease out the influence of climate and weather on the nest outcome. And so we include the nest site, whether the nest was on a marsh site or an island or one of our loon nest drafts. That can make a key difference in average nesting success, as well as the weather variables. And we're benefiting here from this long data record and monitoring. We have a really huge sample size to work with, and so we were able to develop an informative model where all of these weather categories of weather variable, as well as the important covariates, were significant predictors, and we could explain a lot of the variability in nesting success. And to visualize that, I'm going to just show you for one weather variable, temperature, how that works. Loon nesting there's a lot of noise in the data, so if I showed you the raw data for every individual nesting attempt, it would look like a cloud of points across this graph from left to right, and you wouldn't be able to see any pattern. But what I've done here is to bin the points, so each point represents 84 records or nest attempts, and I've binned them by the temperature percentiles so that the coldest 2% of the nests are on the far left of the graph, and the far right is the hottest 2% from whichever year or part of the state they came from. And as you look across the range of temperatures, you're clearly seeing the pattern that captures a climate optima for nesting, apparently here in New Hampshire, across all the temperatures that we've recorded. Nesting success is worse at high temperatures, but it's also worse at the coldest temperatures that we've observed. And I threw onto this graph the last 2 years, aggregated in a different way. Those red dots are 2021 and 2022, average nesting success for the whole state and average temperature in Concord in June and July, just to show that the last couple of years fit this pattern, and that if you look at the vertical bar there, the prediction for 2050 in northern New England for average June-July temperature really is off the charts for what we've experienced over the last 50 years, and will mean a whole different world in terms of loon nesting if this pattern holds true. This curve was present in the data for other weather variables like precipitation and relative humidity, and it makes it look like the model is really capturing the mechanisms that we care about in terms of how climate will impact a key vital rate for loons in the future. As we get that result and have our management informed by that research, we're immediately interested in collecting more data, so we're starting to put out more trail cameras. This is a trail camera on a loon nest raft on Winnipesaukee, but in New Hampshire we have a natural north-south transect to work with from up on the Canadian border down to the central seacoast region in the border of Massachusetts. So we want to collect more data on loons' response as they nest to different temperature regimes. And my coworker Caroline Hughes, here's one of the trail camera images. My coworker Caroline Hughes has done the first round of that as an Antioch student here in her master's work to look at the behavioral response of incubating loons to heat stress. They'll start to pant like a dog on the porch on a summer day, and she wanted to see whether we could help loons by shading the nest rafts with a little more shade fabric on the covers. A simple measure, but what she found was exciting because at those shaded rafts, loons started to pant a little later in the day or at slightly warmer temperatures. They were less stressed at a given temperature because they had a little more shade. So this was a small sample size for Caroline's work, 14 nesting pairs, and there's a big overlap in the confidence intervals you're seeing on these curves. But the difference, the apparent difference here between the shaded and the unshaded raft cover of 1.8 degrees Celsius is significant or substantial with respect to predicted warming. We may be buying the loons a decade or two of time by adding this shade fabric to the nests. And we're looking for ways that we can help, even if it's a small way like that. So those are some of the findings for the fecundity of the population, the productivity, the nesting success. I want to talk about a few of the impacts to adult survival that we've observed. This slide shows you on the left the cross-section of brain tissue from a loon that was collected on Lake Umbagog in 2015. And you can see right there the little cluster of malarial parasites in among the healthy red blood cells in the capillary of that brain tissue. This loon died of an acute infection from avian malaria. It was the first recorded, sort of made headlines in the Boston Globe at the time. And since then, we've collected 5 more cases of avian malaria-caused mortality in New Hampshire. So it's the advent of this tropical disease as a prominent mortality cause in the population. We're also seeing accidents from extreme weather. Global warming is one part of climate change, but weather extremes are another. And in 2021, there was record historical flooding, as all of you know if you're from around here, in southwestern New Hampshire in July. There's a flooded garage and house on the news. And this loon here was washed over the dam on Scatutukee Lake just a couple days after he had successfully hatched chicks from a nest. So it was the valiant search and rescue efforts of Brett Thalen, Russ Cobb, and our field biologist Mary to locate this loon and return it to the lake that kept it in the breeding population. We banded it at release, and it was back this year and nested successfully. We're seeing this uptick in loons that need rescues in the wintertime as well. So with more variable weather and weather extremes, we're seeing less predictable ice cover on New England lakes, and we are finding loons getting stranded as they go through their midwinter feather molt, which usually happens on the ocean. If the lake hasn't frozen over and the loon has stuck around, it may be unable to take off when the ice finally comes in. These 10 loons were in that situation. We rescued them on the lake and took them down to the coast where they should have been. And as we surveyed this summer, we were gratified to find that the majority of them had made it back. They survived the rescue, they survived the rest of the winter, and they were back, in some cases at Purity Lake and Orange Pond, nesting again, producing young, and the rescue really worked as a way to keep them in the breeding population. So they aren't just a doomed surplus or a little fraction of the population that's senescent and stuck for that reason. They just may have been unlucky. As we are stumbling on some of these sort of accidental impacts of climate change and also confirming the ones that we would intuitively ahead of time think might be a problem, like hotter temperatures compromising nesting success, I just want to put a plug in as I close for the kind of close natural history observation that's informing all of that, and the benefit we get from stepping closer to the problem and gaining more insight into the biology that's driving this common loon response to climate change, and the small ways or big ways that we may be able to help. So this is the notebook from our field biologist this summer in the Monadnock Region, Autumn Heil, but it was her observations and the crews and the community scientists who are out there that are letting us do this work. So I'll stop there, and if there are questions.
Thanks, John. Question?
So, predictions are we're going to have more floods, more droughts, more sun, no temperatures. All those would seem to be arguments for putting out more of your artificial nest sites. And what I know from long history, that you're sometimes reluctant to put those sites. Can you elaborate on that?
That's an excellent question. Yep.
So let me just repeat it. So the comment about with climate change, more extreme weather, more severe rainstorms, more droughts might motivate or encourage more artificial nesting structures. And can you comment more on that?
Yeah, it's a great question. There's a philosophical reason to want to keep loons on their natural habitat and to protect the natural habitat, and when we are out on a lake, to encounter loons as a wild species and not just one that's so artificially managed that that's the only reason they're there. So that's been our guideline in the past, and we've relaxed that and started to become more aggressive in putting these rafts out to anticipate threats like climate change, and also coincidentally in the current 5 years as a restoration effort. There's a project underway across the Northeast to offset the losses from past oil spills to loons. And so we've actually, I mentioned 140 rafts going out this year. That was a jump of 40 rafts from the year before. So that coincides with a time when, you're right, we're re-examining that practice and looking at ways we need to be more aggressive. Yeah.
Other questions? Thanks, John.
Thank you.
Before we break, I just want to let folks, we do have some questions. I'm sorry. Go ahead. Where are the locations of the oil?
Of
these
the
sites?
oil spill? Yeah, it's now 20 years ago, 2003, there was an oil spill down on the coast of Rhode Island in Massachusetts, Buzzards Bay, Narragansett Bay, and that killed hundreds of loons and took a long time to settle as a process, but the federal funding to do the restoration work to offset those damages was distributed to loon programs throughout the Northeast. And one of the tools for bringing more loons online into the population to offset those losses is to put these nest rafts out. Yeah.
Yes.
So you're with the Loon Preservation Board, and is there any opportunity, like in the previous presentations, does it help to have citizen input so as we're out and about on the lakes or ponds and observing loons?
So the question is there any assistance that citizens can provide in observing loons, their population, their locations?
Certainly. Yeah, I welcome you and encourage you to go to our loon.org website as an easy way to find it or to get in touch with us anyhow. And we're glad to incorporate, we rely on sort of a hybrid program of a trained seasonal field crew and then hundreds and hundreds of volunteers around the state. Some of them live right on a lake and it's their loons that they're watching, and others are just casual observers who head off to kayak, you know, wherever they want on a given weekend. Yeah.
Was there another question back there? Oh, Brett.
Related to that, you know, we saw these amazing presentations about eBird and a lot of discussion about the use of eBird. And there's also other ways in other presentations today that people can report wildlife sightings, like the National Wildlife Sightings website for Fish and Game. And I just wondered, especially around things like loon nesting, are people reporting that to eBird, or are you worried about data, sharing that kind of data about sensitive locations like nesting? Do you just want people to go to loon.org?
That brings up a lot of, you know, good questions about the sensitivity of wildlife sightings and how to manage the traffic they could create at a loon nest or at the base of an eagle tree or a broad-winged hawk nest, I suppose, if you could find it. But and some of the limitations with standardized portals like eBird for recording the breeding status or the details that we care about when we're, you know, wanting to know exactly, if we can, the day that the loons started nesting. Right now, a checklist format doesn't really necessarily capture that. So we have the system right now that we use is probably best accessed and supported through our admittedly idiosyncratic format, and we are interested in making it compatible with broader efforts like iNaturalist. But for now, it's loon.org. Yeah, and we are sensitive to not publicizing the precise location of loon nests or brooding areas, so that you still have to go out and explore to get that perfect picture. Yeah. Great. Well, thank you.
Okay, thanks, John.